Hi there and welcome to my capstone project presentation. This is about assessing the impact of diesel price volatility, the case for UPS. Today I'll be walking you through my research analysis and determinations on how fluctuations in diesel fuel prices have affected the financial performance of UPS. So this presentation will contain a summary of key components of my thesis, such as my modeling efforts, deployment plans, cost considerations, and recommendations for future improvements. So with no further ado, let's get started. So the initial starting point here was clarifying the business problem. So I identified a core business challenge with UPS is understanding the financial sensitivity of fuel cost volatility. Insight into this is essential for the decision-making process of forecasting, planning, and risk mitigation. My goal here was to determine whether a predictive model could reliably reflect the relationship between diesel prices and operational margin. So there were two kind of outputs that I expected. Either to see a study proving that there's a significant evidence of such, that there is such relationship between diesel price fluctuations and UPS's financial success, or on the other hand, to see that there is something that is stopping that relationship from occurring. Most notably, that was fuel surcharging, but we'll get to that a little bit later. Okay, so the analytical framework. This project definitely carefully adhered to the CRISP DM framework as is seen here. This entire thing we see here on the left is the framework, obviously step by step through this process and to deployment. So once the data set was finalized in Excel, Tableau was then used to conduct the exploratory analysis. From there, I advanced to predictive modeling in Python, and that is where I created an elastic net regression. An initial regression was carried out in KNIME. It was much more simple, and it found a very statistically weak study. So had to shift from that into something a little bit more complex, which proved much better than the KNIME, however, still ran into issues with that one. But the shift from the traditional linear regression to the elastic net did have significance. So the data set took some time to put together. It has quarterly data from Q4 of 2009 until Q4 of 2014, so it is pretty extensive. There are about 62 data points in there. All of that data came mostly from just the UPS financial statements and then diesel price indices that are both publicly available. The key metrics are operating margin, percentage, fuel surcharge, revenue, and diesel price. Those four kind of columns gave a lot of the data that has gone into the model specifically, although the other 22 columns were definitely insightful and have impacted this study. So the comprehensive data set of this timeline of the data set captures both normal and expected price fluctuations, as well as the more extensive fluctuations that we do see over time. Here's just a quick excerpt of the data, the first sort of 5 or 6 rows there, just to reference the outline to you the way it looks in the data set, but not much more to say here. Okay, and then here are my exploratory insights. So these were created with open source software, Tableau. This exploratory analysis has provided an initial insight into how fluctuations in diesel price impact UPS, specifically through its impact on operating margin, which is where the study kind of centers around. So this Tableau dashboard has effectively showcased the relationships and stability of the data over the 15-year period. This analysis has presented two main key insights. And the first being the one I focused on, but so firstly, operating margin, which shows a slight decline during spikes in diesel prices, which confirms a hypothesis. And then second, it does show that consistently in Q4 each year, a consistent reduction. And I suspect this is due to much more shipping, sending, etc. being done during the season due to the holidays. So overall, the recurring patterns observed across quarterly data suggest potential for further applications, including demand forecasting and financial risk assessment. These capabilities are critical for logistics providers such as UPS, as well as other similar companies, USPS, FedEx, where operational and efficiency and profitability can be highly sensitive to change due to the fuel costs. The patterns identified in this analysis at this point support the premise that fluctuations in diesel fuel prices may exert financial strain on UPS. So at this point, we are moving in the right direction, firing on all cylinders. So this is where we kind of get into the early stages of the modeling, and it kind of tells a story. But anyway, as I mentioned before, initially a NIME analysis was carried out, and given that poor performance in the basic linear regression, I implemented an elastic net regression in Python. So that combines both Lasso 1 and Lasso 2 regularization, improving model stability and interpretation. This has allowed for improved generalization and a better handling of potentially correlated input variables. So overall, better handles multicollinearity and variable selection. Next is the model performance review of my elastic net model. So the elastic net model outperformed the initial model, reducing overfitting, and it's also more interpretable. One specific metric that has improved that I was pretty much focused on my number was I was aiming for 0.6, and from moving from NIME to Python, I was able to get an R squared of 0.58 from 0.16, so significantly better, still just short of being statistically significant. However, the model still explains only a portion of the variance, which reinforces the likelihood that UPS margin behavior responds to more complex nonlinear factors that were not directly implemented in either of these models. So the results of the elastic net model offer balanced and interpretable insights and help us in understanding the relationship between the diesel price and the quarterly operating income of USPS. So combining regularization and interaction-aware feature engineering, I have created a model that explains 58.2% of variance. That's coming from that 0.58. So this is moderately but not fully statistically significant, as I mentioned before, and ultimately this model supports the data-driven decision-making process. So I think it's important for us to recognize as an organization that this model is not perfect and it's not deployable at this moment in time, but that doesn't paint the entire picture. Just more development is needed in order to really trust what we're doing here. So this elastic net model as is not recommended, as it may provide misleading results. We care about the stakeholders and the consumers in this case, and it's just not in our best interest to pull the trigger right now. I plan on carrying out further iterations that more closely align with the business identity, the business problem here. So my intended next steps are to include the testing of nonlinear models, as I've identified that other factors equate into this problem. In particular, I do believe I will see surcharges being a major sort of player in this, and that's what's missing from this current structure. And I know that similar surcharge structures exist in competitors. I personally researched FedEx and Maersk over in Europe, as well as USPS. So I do see a strong utility in incorporating time lag variables and macroeconomic indicators. From this furthering of the study, I expect to receive more actionable insights for the betterment of our decision making, which is kind of the goal at the end of the day. So I mentioned both FedEx and Maersk just a moment ago, and I'd like to compare two models that I've come across in my study. So Maersk's Power BI-based predictive model cost $40,000. FedEx's fuel forecast estimate was estimated at around $75,000, possibly more, over a 6-month period. Based on this, I do intend to follow more of Maersk's model, just because they use open source materials and softwares, they use existing internal talent, and they had a lot of existing infrastructure, which I definitely believe we have here at UPS. So that will be our framework moving forward, more so than a very heavy investment at this stage, like FedEx, as we are doing significantly better than FedEx in almost every metric at this time, which is a win. So the solution is lightweight and visually focused, prioritizing interpretability for operations teams. I think that's really important. So where do we start? What is the timeline? What are we looking at? So until Q3, this is our estimated redesign finalization period. And then expecting our pilot deployment in Q4 of this year. And hopefully Q1 of next year will be full deployment. We will trust the model. We'll have everyone in our operations team and financial teams very well versed on what's going on. And it's definitely a key thing on my side that we make sure every single person knows what they're doing, is constantly reassessing, retraining. This is a really important thing for us to be doing. And then specifically what they'll be looking out for are these KPIs, the forecast accuracy, dashboard engagement, and the RMSE, as well as perhaps the MAE and other kind of metrics that show up. So when it comes to monitoring the model and who needs to know, I touched on that briefly, but the model quality will continuously be monitored through the use of a KPI dashboard. The dashboard will be expanded, it will be kept up to date. That is the role of our IT teams and our data teams. If error metrics exceed acceptable ranges, retraining will be immediately required. Regular reviews will maintain accuracy and stakeholder trust. And it's of specific emphasis that these standards be upheld. I mentioned this stuff just a couple of minutes ago. I just really want to drive in that the success of this deployment is dependent on engaging the right stakeholders appropriately. Finance and operations teams will need to understand outputs for decision making, and IT ensures system reliability, and executives need that digestible strategic insights. Next are my next steps and future expansion. So an expansion to this model will be to look at the global fuel market. This study here is just drilled down to the United States diesel prices, as they were accessible and still very applicable and important for such a study. But when we have a strong model cultivated, future challenges, including adapting to macroeconomic conditions, they all play into this same question of fuel prices into our operational margin success. As fuel is obviously a globally valued commodity, the sea's frequent change is different in all regions of the world. US fuel prices are not the same as they are in other such countries as the United Arab Emirates and in the Middle East. So what is my conclusion? In summary, this project has demonstrated that while diesel price has some impact on UPS operating margins, the relationship is more complex than initially interpreted by a standard linear regression model. The underperformance of the NIME model revealed that limitations of overly simplistic techniques in high-dimensional or highly variable environments do exist. This is where we needed to pivot. And transitioning to the elastic net regression model represents a methodological pivot. It acknowledges the presence of multi-collinearity among predictive variables and the potential for non-linear interactions. This more advanced model class balances predictive accuracy with interpretability, offering a path forward that aligns with UPS's operational complexity, of which there is quite significant complexity in any logistical operation. Just to reiterate, further work is needed to refine inputs in order to deploy the model, experiment with alternative algorithms, and stress test the model under different economic conditions. Beyond pure prediction, this modeling process offers strategic value by enhancing UPS's capacity for financial stress testing, risk management, and fuel cost planning. So ultimately, this project lays a foundation for an iterative, data-driven culture within UPS analytics. I think quite an interesting one. Perhaps a question that hasn't been looked into more recently. So the next steps here will be crucial in unlocking our full potential here at UPS. So multitude of references. These are the ones I've directly talked about in this presentation. However, if you look in the speaker's notes, you'll find about 15 other references that are detailed and gone into detail and discussed in the thesis paper. So thank you very much. I hope you enjoyed my presentation. I thought this was just interesting, all of our different logos represented right here, going back to 1919, just showing our success over time. So thank you very much for listening.